40 years have passed since the crew of Apollo 14 achieved the third successful lunar landing mission. And although their names and deeds are indelibly etched in American history, it is easy to forget just how difficult a trip the astronauts endured and how complex the mission was for the engineers responsible for the success of the journey. Commanding Apollo 14 was Alan Shepard, the iconic astronaut who had been the first American to fly in space during the landmark first mission of the Mercury program in 1961. An inner ear condition had prevented Shepard from pursuing his astronaut career for nearly a decade, but after corrective surgery, he was able to convince NASA health officials that he was fit to fly again, and with his assignment to the Apollo 14 mission, he set his sights on a walk on the moon. Joining Shepard on the Apollo 14 flight were two members of NASA's fifth group of astronauts who had joined the agency in April 1966. Edgar Mitchell was commander of the lunar module Antares. He and Shepard would spend more than 33 hours on the moon and make two long moonwalks, including one of the most arduous explorations of the entire Apollo program. Assigned as pilot of the command module Kitty Hawk, Stuart Russo would ultimately make 34 trips around the moon and spend a total of 67 hours in lunar orbit, including more than 30 hours alone in the tiny command module while Shepard and Mitchell were on the lunar surface. Apollo 14 lifted off from the Kennedy Space Center in Florida at 4:03 p.m. local time on January 31, 1971. The initial stages of the flight went as planned until the time came for transposition and docking, a procedure in which command pilot Stuart Russo would maneuver the Apollo 14 command module docking probe into position to extract the Antares lunar module from its storage space in an expended stage of the launch rocket. Russo nudged his spacecraft forward as planned, carefully moving its docking probe into the docking receptacle on the lunar module. He then waited a long moment for the appropriate display on the command module instrument panel to light up, indicating that a hard dock had been achieved. The light, however, remained dim. The two spacecraft had failed to dock. While engineers in Mission Control in Houston began simulations intended to diagnose the problem, Russo made 3 more attempts during the initial effort, and a fifth try about an hour after the first attempt. Time passed, and concern grew that the grand journey to the moon might be cut short even before the astronauts got out of orbit around the Earth. Finally, as frustration grew, an unorthodox solution was proposed. Reasoning that some small debris might be preventing the docking probe from achieving a snug fit, it was decided that the command module pilot would be given a go-ahead to continue his vehicle's forward motion after the two spacecraft made contact, in the hope that the maneuver would dislodge any debris that might be preventing the latches on the docking equipment from engaging. Despite the risks involved in the proposed maneuver, faith in Russo's piloting skills and in the resiliency of the vehicles, which had been designed, manufactured, and tested with extreme care by some of America's best engineering talent, led mission managers to okay a 6th attempt at docking. The risky procedure proved to be the right solution. The crew breathed a collective sigh of relief as their spacecraft finally latched onto the lunar module, which was then drawn out of its protective cocoon within the spent rocket stage. Mission Control confirmed that all was well, and Apollo 14 was cleared to continue its journey to the moon and its rendezvous with destiny.